So, good day, sir. Today I'll be presenting the Smart Home Behavioral Design Patterns demo, which is a Java program that demonstrates the three important behavioral design patterns working together in one system. First is the observer pattern, the command pattern, and the strategy pattern. This program will simulate a smart home system where devices like lights, fans, and heaters can be controlled through commands, monitored in real time, and automatically adjusts based on strategies. So, when we run the program, the first thing that will show up is the Smart Home Behavioral Patterns demo, which which consists of commands, which is the list, which shows devices, the status, which checks all device states, the on and off device to control the device, the set strategy to switch automation modes, and auto apply to apply strategies automatically. This is an interactive console application, meaning we can type commands in real time to control the smart devices. So let's start with the observer pattern part of the code, which the device acts as a subject while the console dashboard is the observer. Whenever a device changes its state, for example, when we turn on the light, the device notifies all registered observers. In case the dashboard automatically prints the updated status on light 1. So example of that is light on light 1. So it says light 1 on level 50. The strategy is energy saving. So instead of checking every device manually, the dashboard immediately reflects that change. That's the observer pattern in action, showing real-time updates. So the command pattern part is every action we perform, like turning on and turning off or changing the level, is wrapped inside the command object. For example, the turn on command encapsulates the action of turning the device on, which is like previously this light 2. So aside from turning on the light, we can also set the command device's level, which is set level light 1 to 20. So there, the level of the light has been switched to 20. When we execute a command, the program saves it into a history stack that allows us to undo the last action. For example, the on light 2, we can undo this by just typing undo, which undoes the last command we prompted. This shows how the command patterns gives us flexibility to execute, to record, and to undo actions, just like a smart home remote with memory. Next is the strategy pattern. Now for the strategy pattern, this defines the different automation strategies for how the device behaves automatically. There are three strategies in this demo. which is energy saving, performance strategy, and comfort strategy, which the first one turns the device on a low level below 30%. The next is it sets the device to the highest output, then the next to the medium output. So if we apply it to a specific device with auto apply fan 1, we'll see applying strategy performance to fan so we can set the strategy to performance. So the strategy for the 4 of them has been switched to performance. This shows the strategy pattern lets us dynamically change the device automation behavior at runtime without altering the actual code logic. What's amazing is how these 3 patterns work together seamlessly. The command pattern handles the user inputs and actions. The observer pattern ensures that the dashboard instantly displays all updates. The strategy pattern allows flexible automation rules for each device. For instance, when we type set strategy comfort and auto apply heater, the system sets all device to comfort mode, applies it to the heater, and instantly displays it. Everything happens smoothly. Commands are executed, states are updated, and the observer reports in real time. In summary, this demo is a great example of how multiple behavioral patterns can cooperate to create a clean, flexible, and interactive system. So next is the UML diagram, which represents the smart home pattern demo, which demonstrates the 3 behavioral patterns. So at the center is the device class. Each device, like a light or fan, acts as a subject in the observer pattern. It keeps the list of observers and notifies them whenever its state changes. Here, the console dashboard is the observer, which plays updates in real time. Whenever a device turns off or on, or changes level. Next, the strategy pattern is shown through the three concrete strategies, which is energy saving, performance strategy, and comfort strategy. Each device holds one strategy that defines how it automatically adjusts its behavior, for example, saving energy or maximizing performance. Then we have the command pattern, represented by the command interface and its subclass. The turn on command and turn off, set level and set strategy command. Each command encapsulates a specific action on a device, allowing operations to be executed and undone easily. Commands keeping the invoker class manages these commands, keeping a history so users can undo actions. And finally, the smart home pattern demo main, which ties everything together. It creates devices that assigns the dashboard and lets the user interact through console commands. In summary, this UML shows observer keeps the system responsive. Command organizes device actions, and strategy enables flexible automation, making the smart home both dynamic and maintainable. Strategy enables flexible automation, making the smart home both dynamic and maintainable.